We have a trigonometry word problem. This question in particular is going to be an ambiguous case when we apply the sine law. So you have a loop of a long piece of a rope, and let's say you're playing tug of war with two other people with the round rope. It's going to, so although the rope is going to be round, but when you're playing the tug of war, it's going to be pulled in 3 different directions. So you're going to form a triangle with the rope. Okay, and the vertex of the triangle that you're holding has an angle of degree of 45 degrees. The distance between 2 of your friends, so that's not you, so the distance between your 2 friends are going to be 2.5 meters. And the distance between you and your friend on the right side is going to be 3 meters. Obviously, it doesn't matter which side, it's going to be one of your friends. The question is asking, what is the total length of the rope if all of the angles that we form with the triangle of the rope are going to be acute? So remember, acute means less than 90 degrees. So first, let's draw a scenario of what's going on. So we're going to have a tug of war between 3 people. So we're going to form a triangle. Okay. Let's draw a triangle. Okay. And let's say you are here. So I'll put Y for you. And friend number 1, we'll call that A. Friend number 2, we'll call that B. Let's see, the angle that you're holding has a degree of 45 degrees, so let's put 45 degrees. So after you form the triangle, this degree is going to be 45. Distance between your 2 friends is going to be 2.5 meters. So that's the distance between A and B. That's going to be, so this distance is going to be 2.5 meters. The distance between you and the friend on the right, so it doesn't matter which friend, so this is going to be 3 meters. And it's asking for what is the total length of the rope, which means, well, we have 2 of the lengths, we just need a 3rd one. Now, I know I drew the diagram in this way. However, you have to be careful that you could have 2 different possibilities when we're calculating for the angles. When we are drawing our triangles, we actually have 2 different possibilities. And the possibility is that we could have, so I actually drew it correctly with all the triangles having acute angles. However, we could have a non-acute angle, which is an obtuse angle. So if you look at the information that's given, we got a 45 degrees, and the distance between the 45 and one of the sides is going to be 3. This is an ambiguous case because when we have the 2.5, we can go from the quarter of 2.5. When we have the distance of 2.5, this is going to be our 3rd side. However, we could possibly have another side over here. Okay. So if I have 2 different possibilities, then this is when we're going to have the ambiguous case. Now, the one I'm looking for is going to be this one. So the triangle that's all in the solid lines, not the dotted one. But you just have to keep in mind that we could possibly have another one where we could have the side that's going to give us one of the angles as an obtuse angle. Okay. Remember, because they all have to be acute, this is not the one that we want. Therefore, this is not the triangle that we want. But when we do the math, we could possibly have this one as our answer. So I'm just going to leave this in there so we can kind of keep that in mind. But ultimately, this is what we're looking for. I'm going to call this little b because it's across from the capital B. So I'm going to try to solve for this, this length. Now, before I can solve for this, now remember, we obviously know that it's going to be the sine law, but right now let's just observe, can we use the sine law? And usually what kind of checks do you do before you can use the sine law? So I have my angle and a side length that's on the opposite side that's given, okay? And I have the length of the other side, and I'm looking for B. Now, because we already have a completed ratio when we have the sine law, I'm going to use the sine law. Okay. So our sine law, we have 2 different versions. Here I will be looking for, so if I set this one up and I'm given this, I'm going to be looking for angle A. So when I write my sine law, I'm going to write the fraction with the angle in the numerator. Although it doesn't really matter which one you use, but I'm going to use a sine law with the numerator, with the angle in the numerator. So my sine law is going to be sine A over, let's call this little a, over, now we have this that's completed already, so I'm going to call it sine capital Y all over little y. Okay, and we could also set one up for B. Let's have sine of capital B all over little b for the other two sides. Okay. So my first step is going to be, I'm going to use the values that I'm given to calculate for angle A. I want to look for angle A. So I'm going to take the completed ratio for y. So that's this one. And I'm going to take this fraction and I'm going to set up my sine law. So I'm going to have sine A over little a is equal to sine capital Y over little y. So capital A is what I'm looking for. Little a is going to be 3. Sine Y, capital Y, so sine of 45 degrees over Y, that's going to be 2.5. Okay, that's the value of little y. Now let's solve for sine. So first I'm going to isolate for sine A. So I'm going to multiply the 3 in the numerator of the other side. So I'm going to have sine A is equal to 3 sine 45 degrees all over 2.5. So that's going to give me, so 45 is a special triangle. So I'm going to use 3 times sine 45 is 1 over root 2. And that divided by 2.5. Let's just clean up a little bit. So sine A is going to be 3 divided by 2.5, 6 over 5. So it's going to be 6 over 5 root 2. This one, I'm actually just going to calculate the estimated version because we can't really do much with this one. Because when we solve for the angle A, this is obviously not going to be 30, 45, or 60. So I'm just going to get the estimated value for A. Now, this is where we kind of have to be careful with the sine law. So this is where it's going to give us 2 different numbers. Okay. Now, once we have this completed ratio, when we are solving for the angle, that's when we have to refer to the CAS rule. So let me draw the Cartesian plane for our CAS rule. Oops. So we're going to have CAST, and we know that this is a sine ratio with a positive ratio. So I'm going to have my 2 terminal arms, one in the A quadrant and the other in the C quadrant. Now, when I put this in the calculator by doing A is going to be sine inverse of 6 over 5 root 2. Remember, the calculators only give us the beta angle, which is going to be this one, or you can think of it as this one as well. So my beta angle, so it's not really A, well, it's going to be one of the A's, but my beta angle is going to be, let's go sine inverse of 6 over 5 root 2. Root 2. So this is going to give me an angle of 58 degrees, approximately. This has been rounded. And if I want to get the other angle, it's going to be 180 minus 58 degrees. Okay, so that's going to be the 180, and then you're going to subtract the beta. Okay, so the answers that we're going to have, or the 2 angles we're going to have, are 58 and 180 minus 58, which is going to give me 122 degrees. Okay. So these are the 2 possible A values that I can have. Now let's take this and let's refer back to the diagram to see which one we have to use. So even in the question it says they all got to be acute, so I know it's going to be the 58 degrees, and we can also verify that in our diagram. So I'm going to use, let me use green. So this 58 is going to be this one. However, the 122, that's going to be the angle for this. So if this A value, sorry, the A angle was here. So if this was my triangle, then my angle here would be 122. Okay, so this will be 122. But is this the angle that we want to use? No, so I'm just going to stick with the 58. I just have to emphasize this so that you know that when we have the ambiguous sine law, that we could have two possibilities. However, we have to choose the acute angle. Okay, so I have my angle. Let's see what the question is asking. So the question is asking, what is the total length of the rope? So I have this one. I just have to get my value of B. So here, to get the value of B, I would need this angle. Okay, so first you got to calculate for angle B. So angle capital B. Let me divide this. Okay. So if I want to calculate this, remember the dotted line, we don't care about the dotted line anymore. We don't have to look at this 122 because that's not what we're looking for. So first let's calculate this angle B. And it's going to be, let's calculate B. Angle B is going to be, remember all the three sides of the triangle have a degree of, the sum of 180 degrees. So all I have to do is just take 180, subtract the 45, and subtract the 58 degrees, and minus 58, and that should give us the angle of B. So let me calculate what that is. 180 minus 45 minus 58, that's going to give me 77 degrees. So the angle at B is going to be 77, so I'm going to label that. Okay. Now we can calculate for the length of B. And I'm going to use the sine law. Or actually here, you could use a sine law or you could use a cosine law. You could use either one. You should be getting the same answers. So you could use the sine law. Again, if you were to use a sine law, then you will use these two side lengths or even these two. And then you'll have to set it up with this ratio. And then you can solve for the length B. Or you can also use a cosine law by using angle 77, 3, and 2.5 and calculate for the side length that's across from 77, which is the length of B. So first, let me just use a sine ratio. So I'm going to take this, which is the completed angle, and instead of this, I'm going to put B. So I'm going to have sine 45, actually sine of A over A. So I'm writing down the formula again so that you see what I'm doing. And then we're looking for length B. So I'm going to have sine capital B all over B. We know our capital A and little a, that was 45, and the 2.5, sorry, that was not A. Oh, that was Y, but I will use A anyways. So I'm going to use 3 and 58. And 58 and sine. We know, do we know our capital B? Yes, we do. That's the 77 that we calculated. And it's going to be length of B. That's what we're looking for. So I'm going to rearrange. I'm going to multiply B on the left side, and I'm going to multiply or divide this on this side, and I'm going to move the 3 over here, multiply it at the top. If this looks too confusing, you can just do cross multiplication and then isolate for B. That also works too. So if I rearrange for B, it's going to be B is equal to 3 sine 77 all over sine 58. So let me calculate what that is going to be. So 3 sine 77 divided by sine 58, and I get a value of 3.4, let's round it to 5. So 3.45 meters, that's what I'll have. And the question is asking, what is the total length of the rope? Well, all you have to do is take the 3.45, take the 3, take the 2.5, and add them all together. Okay. Let me just try this. If you decide to use a cosine law, that should still work. So let's say I decided to use a cosine law. Let's just verify that we can get the same answer of the 3.45. So if I use the cosine law, I'm going to have, so the length that I'm looking for is going to be little b, so b squared, and then we got a squared plus y squared. Those are our other two variables, minus 2ay, and the cosine of capital B. B squared, and then a, our value of a was 3, y was 2.5, and then minus 2 times 3 times 2.5, and then cosine of my angle B was 77. Okay. And let me calculate B. So remember, we're going to put this into the calculator all at once and then root the answer at the end. So I'm going to have 3 squared plus 2.5 squared minus 2 times 3 times 2.5 times cosine of 77. And I'm going to root that number. And I get the exact same number. After I root it, I get 3.45 meters. So I got 3.446, but once you round, you get 3.45. So it doesn't matter whether you use sine law or cosine law. The length of B is still 3.45. So to complete our question, what is the total length of the rope? So it's going to be 3.45 plus, what were our values? 3 and 2.5 plus 3 plus 2.5, and that is going to give us 3 plus 2.5 plus 3.45. This is going to give me 8.95 meters. So we're going to say, therefore, the total length of the rope is approximately 8.95 meters. Okay. So this one, I guess, if you just use your calculators, you didn't really have to consider the ambiguous case, and you would have still gotten the same answer. However, it's just recognizing that you could have two different possibilities and then just picking the right one, right? In this case, this one had to be acute, right? But if I say one of the sides has to be obtuse, then you know that you have to take the 122 degrees, which is going to change your answers in the second part over here. Okay. So that was an example of a word problem with an ambiguous case.